Okay, even this one. Did you hear that voice?
Mm.
All right, it's fine. At least it makes sure that I don't speak. Okay, C is equals to N over V. So my
Yeah.
number of moles at equilibrium is 0.775 divided by the volume of which is 2. So this divided by 2
Manori nga ka na le concentration ya eng?
of this one. That's why everybody's at this value.
Okay.
Then concentration
Oh, okay.
is 0.387 mole per decimeter cube.
Mm.
Okay, so this one gets like 0.39. Now, according to balanced equation, again, no, but this is concentration, it's not number of moles. According to balanced equation, this is half of that. Do you understand?
0.775.
This is half of, yes,
Ke half ya 2 minus x.
yes. So you can do this. You can say, let me write with a different color. You can say 2 minus x is equals to 0.775. 1 is half of 2. So
Yeah.
1 is equals to 2, you multiply it by 2. Now I can see 2 minus times this. 2 into 0.775 is equals to 2 minus. So x is equals to 0.45. That's the bigger things. So replace x at this value,
Okay.
then you get value stop. So nale 0.455. The difference of the two, we have 1.55, 1.55. N. Now n is equals to c over v. This divided by 2. It's no n is equals to no c is equals to n over v. So v is equals to 2. So 0.775, 0.775. This will be the concentration. Now, Kc value. Let's hope I reasonably this thing correct. Where's my rub? Can I rub? I'm going to need the left. Hello.
Tato,
Yes, Kabalela.
wangkutwa.
Yeah.
Wow. Ask easy. A ke tsere ne go diragalang nna.
Can I rub more?
Ma ke lost o itse ko genne mo kae mo 0,45. Yeah?
Okay, I don't mind repeating. Don't worry, I don't mind repeating. Okay, before I rub and go to calculating, let me just re-explain. I'm gonna looking at the picture.
Yeah.
Looking at the picture you gave me, we got the mass of H2O. But if you get rubber more,
Mm.
but if you the mass of H2O, ne? But get 36 grams.
Mm.
Then we have the volume.
Mm.
Volume America fela mo. Besides
Yeah.
ne? Sharp.
Mm.
Then we also have number of moles. Thermal change. We have this. We have this. This.
Mm.
So this is a given the 36, the mass at this thing. So when they give us 36, they automatically give us this. So this is given and this is given. The rest of the table is given.
Mm.
You understand? But we know for a
Yeah.
okay, ngana ka bolela no go tlo ngare network na yo sokodisa.
Yeah, kana bolela.
Okay. And then we know according to the balanced equation, water and H2 they are proportional or they are equaling the number of moles. 2:2. Ne? So when they change equally, they will change in the ratio of 2:2. So that means change here this one and change here this one, they'll be the same thing.
Okay.
Now, what I know is that change of this is half change of this. That for this guy is twice this value. So Otley 0,225 times 2. Multiply this value by 2. You have to get this one. And you also need to get this one. Why? Because you have 1. For you to get 2 and 2, you need to multiply by 2. That's how we got these two values. So now our table looks like this. We have, let me write this purple because it's different. Now so far we have this, and we use this to get this and this. So these are the only things we have now. Ne? So for me to get equilibrium number of moles, for me to get to here, I take these 2, I minus this one. That's how I got here.
Yeah. M2 minus 0,45. Okay, I get it.
You get it? Ne?
0,55. Yeah.
Okay, fine. That's how I got the. And then now I know for sure I know what E is equals to I minus C. Yeah. I want to see something.
Yeah.
And a certain amount of carbon. Oh, Oh, oh. Amanyana ne ke sa check something ne. O tla ntshwarela na.
Okay.
I made a mistake here, but it's not a big one. Your statement says initially you have 36 grams of steam. Ne? So I nearly forgot, or H2 is a product and carbon dioxide is a product. Ne? So when they see that,
Okay.
these two values have to be 0. Initially, that is the
Hey, hele eng?
I get it, the statement says initially. Initially, we have 36 grams of steam. Okay. Yeah. So since it says initially
Yeah.
36 grams of steam and a certain number of carbon, that means we only have H2O and C. Other stuff don't exist yet.
Oh,
That is before the reaction.
okay.
Why one?
Mm.
Okay.
So it's gonna be 0 more.
That's why I replace take as 0. Now we have
Okay.
that is purple. So now everything is going to change. Ne? Since I have 0 and I have this value, I minus this, 0 minus this is still this. 0 minus this is still this. Okay? So that's where my mistake is. So can I rub? I nearly made the wrong stuff, yo. So okay. Okay. Now this form I apply this formula or E. Ish. Where's blue? My E is equals to I minus C. Okay. So now 0 minus this over E. So that means over here I still have 0.225. Here I have 0.45. But since here I had 2, and then can I used this to calculate this and that. Ne? So this minus this is equals to this, but this minus this is this because initially there was nothing. You understand why these two can be the same? Here they are the same. Initially there was nothing. So if we take the initial value and what has been produced, we have what it has been produced because initially there was nothing of this. But initially there was something. Then we minus the change.
Okay.
What do we have remaining? We have the subtraction of the change, the difference. I mean. Okay. So now this value is correct. This value is wrong. So this value is also wrong. Okay. Okay. Now we have to take these values now, divide them by 2 or get this one. If you divide this by 2, how much do you get? Okay, 0.113.
0.115.
So if it is 0.45 divided by 2, then I get 0.225. Okay. Now we calculate our KC. Okay. Kc is equals to concentration of products divided by the concentration of reactants. Ne? The concentration of products, this is products. So we have this one 0.225. Because of these two, it's squared, which is 0.113. And then concentration of reactants, we have 0.775 squared. We don't count this guy because this guy is a solid. Now, 0.225 squared multiplied by 0.113 divided by 0.775 also squared. So our Kc value of 9.53 times 10 exponent minus 3. Do you have a final answer of this question? Never.
Hi, Wangu.
Yeah. I was asking what the final answer of this question.
No, I can know.
Okay. Good question paper, Yani.
2020.
All right, no problem.
Get penny.
What again?
Yeah, this year. Ke April ya this year, mara engwe November 2020.
Okay. No problem though. So yeah, this is the value. Ne? Now, do you have another question? Like, I get when you said you are practicing on bots.
Yeah.
I want to solve them. If there's a need, then you must go back and analyze. What I want, although I took time to solve this question, I want to be slow enough so that you notate whatever I'm doing down. And then Okono revise
Couple we repeat.
No,
like
I don't mind.
Yeah.
I definitely don't mind.
La pileur. Okay.
Come in. Okay, so now I'm going to erase everything. Eh? Wait a minute. It seems like here I can increase it.
Yeah.
Yeah, I can increase. I can. Wow. This is nice. This is way better than Microsoft. This. Okay. Now I'm going back to the scenario as if when I
Yeah.
Okay. So the equation again is we have H2O. It said we had steam. So we have H2O, of which it reacts with carbon. It's a reversible reaction. Then it forms hydrogen gas plus carbon dioxide. So this is two. This is two. This is a solid. This is a gas. This is a gas. This is a gas. Ne? Okay. Now the question says, asset art. I think yeah. Even staple. Oh, also the sticks out. Okay. No, it's fine. I didn't even check on I'm going to use it. It's confidential. I just pressed print. And if I can move up for a few minutes, it is 2 minutes.
Yeah.
For this. Okay, Lefa.
Hi. I'm
Me,
here.
I'm back. My name is Tato. This is my sister. Okay. Okay, your picture says initially we have 36 grams. Initially we have 36. No. Initially we have 36 grams. 36 grams of H2O. Ne? So since vele on the chemical equilibrium table, we deal with number of moles. Why don't we just convert this into the number of moles? So N is equals to mass over molar mass. Mass is 36 as given. Molar mass is equals to 2. These
18.
two mass of not these two but these two. Mass of hydrogen plus 16. So this is 18, which is equals to 36 divided by 18. I think this is equals to 2.
Yeah.
2. Now I'm going to, we need this value. We need this value. Yeah, we need this value. So I'm going to shift to this guy. Okay, let me wrap first. I'm clearing this page. I feel like there is still viewers too much. Oh, I can do this and I clear everything you say. Okay. Your stick. Please keep in mind, you did what I just did. Wait, what's the facts?
Yeah.
Are you sure? Or you want it back? Yeah.
No, okay, it's fine.
All right. Okay, remember we just found the initial number of moles is 2. Since we know it, you will see that or why they calculated it before. Now I am drawing my rice table. Oops.
Anisa kwasi kutlala.
Okay. Here we have H2O. Here we have this guy. Let me just add him for peace sake. Last example, I didn't write him down. For peace sake, it's H2, then I have CO2. Okay. Now, initially, this one's it's 0 since they are products and they were not in the container. This one, it's a question mark. Why give you a question mark? Because they said a certain amount of carbon were placed in water. I mean, in container. But so we don't know. We don't know. Then this one we just calculated.
Yeah.
2. The calculation we just did before drawing the table. We wanted to get this value. Ne? Okay.
Yeah.
It is further given that the change in number of moles of what? Of wait a minute. At equilibrium, it was found that the amount of carbon changed by what? Was I doing this question? It's carbon, not carbon dioxide.
Yeah. Article. Yeah.
Not again, one more carbon dioxide. What's some left?
Like support.
Okay.
Kan dete. Kenapa ba? Kan dete.
0,225.
And then carbon it's C mos. It's S mos.
Yeah. No, I understand why. Understand why. No, we were right. We were right. So this is the change in number of moles. I get. Okay. But again, carbon and carbon dioxide, they have the same ratio.
Okay. Yeah.
You understand?
Yeah.
Then here we have 0,225. Then here we have double of this because of these two.
Okay. Yeah. Yeah.
4,
So it's 0,45.
0,45. I left the two out here because of this two. Okay. Now we want to calculate the equilibrium. E is for equilibrium number of moles. The formula is E is equals to I C. This minus that is 1,55. This one we're not interested in it because we don't even know what's there. And then this one, it's this minus this is equals to minus 0,45. And this minus that is equals to okay. Now, if we want to find the concentration, C is equals to N over V. So this divided by 2, this divided by 2 is equals to, this is 0.5, this is 0.25. So I think it's 0.76 in total. Let me verify with the calculator.
Wait. With our 1 comma. Oh yeah. Right.
I'm wrong a little bit. It's 0.775. So at least Lengangwala is 0.8.
Like, is it okay to what's the word? Who can never be who round off more table?
No, I'll advise you to keep with the original values, then only round off the final.
Okay.
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 Fine. Now, if you divide this value by 2, you get 0,225. Come in, ne? Because yeah, because it's this divided by 2 again, and divided by 2 again, you get 0, I think it's 1 something.
0,1125. 1125.
It's 0,1125. So that is your concentration of each. Ne? Okay. Let me do this.
It is a must, isn't it?
Yeah, it really is. We just need to do more so that after today, there's no need to come back to KC. I don't mind doing only KC questions until you are done. Ne? Let me
Okay.
let me wrap this. Okay, and then let me shift you to do this. Okay, I just want to write these values here so that it's 0.78, and then for you it's 0.225, then it's 0.1125. Okay, then I can erase everything here. Okay, now I'm calculating KC. Under the question says calculate the equilibrium constant. So our equilibrium constant is equals to change in product, concentration of products multiplied divided by the concentration of the reactant, which is equals to concentration of product. My product we have 0.225 squared multiplied by 0.1125. This squared is because of this two, ne?
Yeah.
Okay, 0.78 squared. Now give me the final value for this, please.
It's 9.48 times 10 to the power -3.
9.48 times 10 to the power -3. Okay. So this is your final KC value, 8 marks for that sweat.
Yeah. Okay, I get it now. Nikikhakhela ke mo change. Like the whole
Yeah.
the whole ratio thing. Ke re ne ke tlhakatlhakantsha ke mo change.
But
Yeah, because like yeah. Wankutla.
yeah, you can speak.
Oh. Yeah, like what if the balanced equation is
Okay.
not like ideally, like what if it's 3 and something and something?
It's okay.
Like does that mean like is it the same procedure?
Yes. If you have another question there, we can do it, and I can also check question papers on my side so that we deal with it. At least it's a complicated thing under the equation.
Yeah. Kopela o check because na impetila fetsa ka tlohela.
Which
Maths.
which one?
Yona if re fetseng ho ira no. So kana wa check like from your side and for ya ka ina le di question paper ke tla ina kama.
Okay, Emanyana, no so, or what can I check?
Kana wa check like one last question from your side.
Oh, all right. Coming. Okay, no problem. Okay, if you have to have more document, then you really can't see my screen. Kung yaga yo black sa manyan, kaya batla yo sorry nga nga device na. No, but we have to learn. Kaya batla password learn na keso nke ka wena. But ke mo teach it at least and then o the syllabus or that's why I'm willing to spend the extra hour doing that. Yes, I'm still checking some question papers. I'm going to mute my mic.
Okay. Grateful for today. I'm so grateful. You're so beautiful. Grateful. Tato.
Yes, I'm still here.
Oh, okay.
Yes. Mm, Kiran Jyoti, what is it? Giving other like question papers, understand?
Mm.
So don't worry, I didn't like disappear. I'm still here. Ke batla ho check di preliminary if more website thing. Okay, but it's 2014. Okay, 2014 is too old, but let's see. Let's see if 2014 can help. Where were you 2014 when? Live.
Hmm? Hmm?
No leg I got 2014.
Nekelo ko. Yeah. Ko ba binaput.
2014.
Yeah, nikira grade 7. Kanete.
14.
Yes. Pati nikira. Akira ke thomile grade 10 ka 2014 grade 7, 2018 grade 8, 29, 20. Que mala mierda que la pila. 2014 grade 7, 2015 grade 8, 2016 grade 9, 2017 grade 10, 20, yeah, nikile ko grade 7 ka 2014.
So how
Nikile munyane.
now very omunyane numus.
Oh, kumuhulu thatone,
Umuhle mo batla
please.
go bona. Ha o batla go bone kantle.
Kumunyane ka mmele.
Yeah,
Yeah, mara age.
ona mmele o go munyane.
Thata.
O tle ke batla go tshega.
Angasitli na konseha.
Ga se o tshega.
Angasitli. Oh yeah.
A ke tla zama o se o tshega.
Yeah, it's okay. Ke mathati. Ke ne ko gina we beats like a save.
O ba le dombulo.
Engi?
O ba le dombulo.
Tata. I give
Mira,
up.
wa bona
Why can't Euclid in geometry?
yeah, I do, but I still need to revisit it because a lot of people are copying Euclid. I don't know why. That's why I say really video ya thing. But I can. It's just water under the bridge. You want Euclid?
Can I read a revision ya paper 2 as a whole, like, you know, paper 2, because I feel like paper 1 can focus more on a thata.
No problem. I have no problem with that. Absolutely. Um, I'm printing out as you speak. I think you can. I think you can hear. I think you can hear.
Yeah.
Question six. Question six. Okay, but now so far, Mohammed, the most difficult chapter for you. Okay, chapter man, come in. I said come in.
For Naki, um,
Hausa Bulel.
oh, as is Naki o na le someone, so go on. Okay. For me, ne,
Yes.
it has to be Naki sure. It has to be a trigonometry, especially when it comes to like 3D shapes. Yeah. And then
So three.
trigonometry
Okay.
and then clear. Hanga khona trick like korvala mnati bushigo ithi. Yeah. Cause kenya ko kra total mo teng mo bo. Cause ina di masinki and then yona le iklidieni wa bona. And then analytical guy khona nyana mara yo when it comes to doing like those questions, the questions are thing. It tricky like yo, it tricky.
Okay. Analytical geometry, no. There are certain questions, Loring, you just have to be smart when you're tackling them, understand? Like, it's more like functions. Yeah, it's more like functions, analytical.
Yeah.
Nice.
Yeah.
I'm teaching, please keep it up. Yes. So, okay, no keep printed the second paper, then we are doing it again, because
Okay.
I go back to have one paper, then when we solve it, then give us 10, I go happy, or something, get another paper. There's this senior certificate exam, okay, year 2018. I want to print it. Let me see. Question six. There are seven, no? No problem. Oh, here is a graph. I love it. Interpretation of graphs. Yeah, question six, print. Oh, what pictures?
Maratatu, do you think it will pass or not?
I really do think you will. The problem go when you wanna which is gay, you know why?
Kirangi?
Which is you need to suffer. Honestly, you need to suffer. Honestly, you need to. I'm not lever. Did I check the first time you
No, I think slow food, but they're so full.
I used to go to school to cross night, but no one and my mom was leading me. I used to
Ah, kasi kasi yo.
like it doesn't need intelligence, it needs repetition. I wonder if you can repeat like not like repeat the same question because auto master question, not the content. Mara,
Yeah.
you need to have more practice, more and more practice. If need be, do all questions you can ever come across. If need be,
Yeah.
all questions you will ever come across.
Yeah, ne?
Yeah, because as long as you can do that, you get used to the style, you get to discover things by yourself. There are certain things you just need to discover when that's it. Okay, I think I'm back. Let me create a new page again. The last time I checked, I was recording this. I hope it's still recording. Yeah, it's still recording. Okay, what's my speaker? Champagne pay. So, should I start with 2014, 2014, 2018? Which is your favorite year? 2014, 2018?
2014.
Okay.
Ke prelim ya teng.
Eh? I say prelim. Ke di final.
Ke prelim.
I cannot do prelim. I need someone.
Okay.
I don't know.
All right. It's fine.
Okay, I'm back at it. Let me do something like this. I don't know how to question whatever now, yeah. Unless if I can download it. You said 2014, I guess.
Yeah.
Okay. Open. I want to see what I get 20 money in. Perfect. So if I go to WhatsApp and send it to you, document. So go to downloads. I'm sending you what I have now. It has to be Gamma downloads. What the heck is it? Okay, so it has to be Gamma for my web. Paper 2 November 2014. Okay, download the guys. Like it is downloaded the guys. Documents. Downloads. Didn't okay, cancel. Open in folder. Show in folder. Yes. The camera the printouts. All right. Okay, you should receive a question paper as you speak.
It's what's Oh, yeah.
Okay, we are solving that one. Let me also download 2018 because we are going to use it. No, wait. But I prefer 2018 for this one is fine. Um, 2018 Department of Basic Education. Okay, I will just send you the picture of this 2018. Now let's solve the question. It says 2014 again. At
Yeah.
a certain amount of nitrogen dioxide, Okay, question 6. I'm sure it's. I'm not so sure. Hold on, too fast.
Mm.
Okay. It says a certain amount of nitrogen dioxide gas, it's NO2, is sealed in a gas syringe at 25 degrees Celsius. Um, when chemical equilibrium is reached, the volume occupied by the reaction mixture in the gas syringe is 80 cubic centimeters. The balanced chemical equation for the reaction taking place is, okay, I'm going to note it down in the screen because balanced equation is a necessity to know. Why does it seem like I always lose my pen? Okay. Mara wena o di utlwella le piano o re utlwella gospel fela o utlwellang forafora.
I'm a piano. I don't listen to piano. It's just like I vibe, no. Hey, I vibe, like I dance and everything. But for Naki ukulele, no, 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 no.
I don't believe you. Anyway, it's fine. Let's avoid it. The first question 6.1 says define the term chemical equilibrium. Ne? Definitions they are yours to learn.
Mm. Yeah.
Okay. Now, second question says at equilibrium, the concentration of nitrogen gas is, so we are given concentration at equilibrium.
Yeah.
We are given a concentration of NO2 at equilibrium is equals to 0.2 mole per cubic decimeters. Okay. What else? The equilibrium constant for the reaction is 171. Okay, Kc equals to 171. So now we have Kc, we have concentration of NO2. Question says, calculate the initial number of moles of NO2 gas placed in the syringe gas or placed in the gas syringe. So Babata, the initial number of moles. This question, you work in reverse. And you remember the previous question, we started from above, from the table, Raya Kc.
Yeah.
Now restart ko Kc, Rabolla go table, reverse process.
Mare na le volume ne. Or e ka se be, e ka se tlhokagale.
You do have a volume. I don't see where we need it, but you do have a volume.
Okay.
Okay. I'm not so sure, but I think we won't need it. Ne? Okay, now, since we have the Kc of 171, it's 171 is equals to the concentration of the product. Concentration of product is given as this. Ne? So we have 0.2 mole. Since it has a coefficient of 2, it's squared. Okay.
Mm-hmm.
Now, the concentration of this one is unknown. So we write it as concentration of N2O4. So what can we do here to get this? We exchange. Now, this this comes here. I remember this thing, it's only this over 1. I get it. So we cross multiply. We cross multiply. If you cross multiply, this will be what? It will be 117. The concentration of N2O4, which is equals to come in 0.2 squared. Ne? So you divide by 117. This is 7. You divide by 117. 117 cancels. Okay. Now, what's left in the equation is the concentration of N204 is equals to 0.2 squared over 117. Let's find that value.
It's 3,42 times 10 to the power negative 4.
Okay. We have okay. This is our concentration. Ne? Now I'm going to redraw our rice table. I'm going to redraw our rice table.
Yes.
Okay. So redrawing our rice table, we get. Wait. Are you done noting here so that I can rub?
Activate.
Now I've got a smarter whiteboard. Instead of rubbing, I can go to the new page.
Asibonge.
Yes, the technology. Check. Oh, yeah. So this is the new page. Now, if we get our rice table, okay, let me rewrite our balanced equation again. In small, it's 2 and 0, 2 plus, okay, no, reversible reaction N2O4. Okay, now drawing my table. Okay. Okay. For concentration, we got for N204, it's 3,42. 3,42. So this is 2 N02, this is N204. So it's 3,42 times 10 minus 4. Okay, and the concentration of NO2, it's given to be 0,2.
Yeah.
Now, this is concentration, I get. Remember the formula for C is equals to
Yeah.
N over V. Now, what do we want? We want N. So N is equals to CV, curriculum vitae. And our C in this case, when we look at this one, our C is 0,2. What is our volume? Our volume is 0,8. Is it 0,8? Mostly we
Yeah.
mostly we use decimeters. Ne?
Volume. Yeah.
We are given 80. We are given 80.
Yeah.
So now
80.
So it's 0,08
Oh, yes.
decimeter cubes. Understand?
Yeah.
All right. Now
Yeah.
2 into 0,08. What is that?
Is the 6.
Thing?
Never a number of moles. What questionnaire?
It'll calculate
0,16.
is 0,16.
Yeah, the answer.
0,016.
Oh, yes. I see. No.
Now,
Yes, 0,016. Yeah.
now this is what we have so far. Let me let me check again what can we use. This is
Try and calculate the initial number of moles.
yeah. So we want okay. So we know
Wait.
No.
Wait.
Oh, must I wait? All right.
Yeah. I get a sharp we recreate 0,016. So this 0,016 give for NO2 I get. So get the number of moles at equilibrium. How do you know?
How do I know? Okay, good question. I used the concentration at equilibrium multiplied by the volume. So and for the number of moles at equilibrium, because I use concentration at equilibrium.
Oh, okay, cool. And then at this side, 2,
2,74.
2,74. We
I replaced this value with this one, and then this doesn't change. Volume is volume.
Oh, okay. Oh,
You can check this.
N2O4. Concentration is Oh, wait, 3,42 times 10 to the power 4. 3,42 times 10 to the power minus 4. Okay, yeah, Kaiwan.
So it makes sense.
Yeah. Mara, why is it to the power negative 4? Nakita. I'm going to get 3,42 times 10 to the power negative 4
Yes.
multiplied by 0,08.
Yes.
Yeah. Nakita 2,74 times 10 to the power negative 5.
-5. Okay, then
Yeah.
I guess in that case I was wrong here.
Mara, iche, what if I get wrong?
Let's hope you're right. Let me check. So it's 3,42 times 10 exponent minus. Yeah, you're correct.
Yes.
I just did this and this. Then Gangwala that thing here.
Yeah.
Okay. Now remember, Hori, initially you only have a reactant and we have 0 product. So here it will be 0.
Yeah.
So meaning I minus
Mm-hmm.
of which it E come in. So when you take remember I said E is equals to I minus C, I get now, but our I initially it was
Yes.
0. So otlongwala the same video and one more.
E kgopela go ira so ke bona. The power negative 5. Oh yes, yeah. Sure.
Do you understand it? Okay. Okay. And now this there was certain number of moles initially. We don't know what. Ne? But what we do know is that according to the balanced equation, that's why the balanced equation intervene here. The ratio is 2:1, meaning this is twice as
Yes.
much. So we multiply this value by 2 to get this one.
Yeah.
Okay. Times 2 is equals
Okay. Okay.
to, I get 5.4 7
Yeah.
10 exponent to 5. Now I add the 2 to get this. Remember when I come here I minus. Now I add. Add 0,016.
Wait. Okay. We already 0,016 minus we already 5,47 times 10 to the power 85.
Yeah, I said. So now when you Emanyan, overlay which value?
Yeah, initial, yeah, and O2. You said 5,437 times 10 to the power negative 5 minus 0,016.
No,
It's a
I added them.
or like the other way around.
I added them. Remember,
Okay. Oh, yes, yes, yeah, kabona, kabona. It's just, kalanya can be. Oh, yeah, kabona, because now I use like, sorry. Okay, I get it. Wait,
okay.
5,47 plus 0,016. Okay, I get it now.
Now you get it, ne?
Yeah. 0,016 055. Yeah.
Okay. Amayan, I want to check something. Ne? This values Casey was 117. No, 171. I wanna do something.
Yeah, KC reference 71. Calculate the initial number of moles of NO2 placed in the gas syringe.
Okay.
Yeah,
It's it's 02 to the reactant.
Titi. Hey.
Di-taxi, man, tolo bitsa di-taxi, check. This is what we calculated.
Yeah.
Yeah,
Our concentration, yeah. Then,
I am wrong.
kublinkele extension de changara ya kakanche.
You. We are
Right.
wrong. No,
Wrong.
yes. No, the whole step is correct, but you made a mistake. What
Yeah.
formula? Changing concentration of what?
Okay. Product over reactants.
Okay. This is this. So it's a reactant that are supposed to go down.
Oh, yes. Yeah.
Up.
Nakabol. Sorry. That's case.
So
Then,
the whole thing, it's wrong because of that mistake. So that's what, yeah? I want you to do it, fixing that mistake, and then put the final answer. Yeah. I'll be waiting here.
yeah.
All right. I'm
Yeah.
I'm going to have the question with you.
Yeah. Thank you.
Sure.
Yeah. Get to the question. Sing, oh baby, water is coming to the sea. Though you are empty, I am the well. Love me, I will provide. Oh, sing. Okay. So we have concentration. Body at equilibrium, the concentration of NO2. So concentration of NO2 at equilibrium is 0,2, right? 0,2 ppm. And we have volume, which is V equal to 80. Is it 80? Yeah. So we're gonna convert it to dl. it's gonna be DM. Right, and we have KC as well, which is C1. So we know that Kc is concentration of products over concentration of reactants. Kc is 171. Concentration of product, we don't have it. It's N2O4. Concentration of reactant, we have it. It's 0.2 squared. So now to find the concentration of our product, we're gonna cross multiply. So it's gonna be 1 multiplied by 0.2 squared, and it's concentration of NO4 1 divided by, multiply, dude. Yo, 1 multiplied by 0.2 squared. What's 6.84? Really? Yo, all right. So this is what 171. Okay, we do this 0.2 squared. It's 0.04171 multiplied by answer. Yeah, I guess that's the right answer. Then my rice table. I have my rice table here. Okay. So my rice table. We have and I have N2O4 as my product, right? Then I'm gonna I have concentration, so let's start. I have concentration. I have concentration, yeah, both. So it's gonna be concentration of reactant, it's 0.2. So I place it here. Concentration of product, it's 6.84, the one that I got right now. Then it's gonna be sharp. So now I have concentration and I'm looking for number of moles at equilibrium. So I have concentration and volume. So we know that the formula is C is equal to N over V. So I have concentration and volume. So obviously N equal to C times V. And then for my reactant first, let me write it down. For NO2, N is equal to C over multiplied by V. My concentration is 0.2, my volume is 0.08, and I have my final answer is gonna be 0.016 moles for my reactant. So I place it here as well, 0.016, right? And then for my product, it's the same thing. N is equal to C times V. Concentration is 6.84 multiplied by my volume 0.08, and it's gonna be 6.84 multiplied by 0. Yo, no ways. How can I get the exam? It's exam season. They can't come. 0.54. Let me just say 0.55 your moles, right? Then it's gonna be okay. Now I I place it in my table, and it's moles at equilibrium for NO2 N2O4. So it's gonna be 0.55 Yates, right? So now we know that, okay, at initially our product, we don't have anything, so it's gonna be 0 according to that. And then our change now is gonna be, I know that my formula is E is equal to I minus C, right? So I have, according to my ratio, my balanced thingy, it's 2:1. So my ratio is 2:1. So it means that I get it. Two of these. Sorry. Changing number of moles. So it's gonna be the same here. I think 0.55. Yeah. 0.55 multiplied by 2, because my ratio is 0.55 multiplied by 2. That's 1.1, right? And then multiply by 10 to the power -5. Okay, I think I'm on the right track. So in order for me to be able to find my number of moles initially, I'm just gonna say at equilibrium, it was 0.016 is equal to I minus changes 1.1, and I'm just gonna add them. It's gonna be 0.016 plus 1.1, and then it's gonna be 0.016 0.016 plus 1.1. It's 1, no, this is odd. It's a very odd number, but I guess it should be 4. So it's 1.1 to, I think so, but I need explanation more now. Explanation and the change happy. Okay, Tato.
Yes.
I think I'm done.
Oh, according to Tato, you're done. What is your final answer?
1.12. If wrong kukela school.
Ganit.
Yeah, if you're wrong kukela school. Answer ke
That's why I can wala this thing. The memorandum doesn't necessarily show the steps. Let me send you the picture. But at least according to Tato's method, as you said, we have the steps.
But then I would like to have an explanation with more that part ela uringi initial moves modi product, like, is it always gonna be 0?
Yes.
Okay.
Yes. You talk more over 0. The only time you have something Chemody reactants.
Okay, I get it.
Does it make sense?
Yeah, it makes sense. Plus, wow.
I sent you the memorandum there. You got the final answer correct.
Yeah, kind of.
And
Yeah.
they don't even show the steps. Okay.
Hey.
We have been in class for I think 2 hours. I'm giving you a question, another question. But this one we're gonna make it next time. Ne? I want you to follow the steps we did. This question is slightly different. Let me see if there's something that I need to do here before. Calculate the equilibrium constant Kc for this hypothetical reaction at room temperature if the volume of the closed container is 3. Okay. The equation below. Okay. Okay, come in. The letters X, Y, and Z represent the number of moles in the balanced equation. Wow. Okay. Oh, I can see. I'm giving you an equation. It's interpretation of graph. It's your homework. Do it. If you're going to be wrong, so that we solve it. Because really a forward process of Kc, and then the questionnaire knows okay the reverse process of it. Now go for a graph, it will be interpretation of graph, then we solve it. Then we know all methods of calculating Kc.
Hey, okay. All right.
So go for this one as homework. Then I will we'll discuss it together, né? So that when I solve it, you also hear my reasons why I do it this way, why I do it this way.
Yeah. Yeah.
Okay. The question should be in your WhatsApp by now. Okay, I'm ending the class and I'm stop sharing. Ne? Any question that you want to ask? Any question that you want to ask?
Okay. Oh, actually, the physics paper one like revision.
No problem. When I just
revision, like I wouldn't.
Okay, when I just tell me okay. Remember, when like moloring tato, you feel like you are weak on it. Then okay. Tato, kita lamu plugging area na kya so called. And then intrinsic that part. Because now if you say the chapter that you know, not the chapter that you need.
Oh, okay, yeah.
Okay. Just send me or tato get so. Then get okay, this thing you can do this it when so that you get me prepared to answer any question.
Okay.
Understand?
Yeah.
There are certain chapters I can do them at any given time. There are certain chapters because sometimes you get deviated from a grade 11. So I want 100% be a stay input grade 12. Understand? Okay. So I'm going to end this class now.
Okay. Thank you.
Sure.
Sure.